Hi, my name's Reagan Russell, and for math study skills, I will be doing my project over learning factorials. So let's get started. So let's start off with what are factorials? Dictionary.com defines factorials as the product of a given positive integer multiplied by all lesser positive integers. Example, lowercase n explanation point. Also, another example that we have is the quantity for 4 factorial. Sorry. And of course, just like the end, we are replacing that with the 4, and basically we are going to be writing out, so basically counting to 4, we have 1, 2, 3, and 4 multiplied by each other, and that gives us the answer 24. And that is the factorial for the number 4. Factorials are commonly used when finding probability, but is also known from permutations and combinations. So we are giving we're finding the probability. We are not finding like the actual number, the exact number for something, just a whole number when finding this probability. Before we start, I want to remind everybody that the factorial of 0 is 1. So, of course, we have the example 0 explanation equals 1 as the factorial. And I'm also pulling up this chart, and it gives off factorials of basic numbers. And so, of course, we're seeing that lowercase n as the integer, and it goes from 1 to 6. And it also on the side is giving the equation right out. And so, as we can see, we have, 1 equals 1, and then 1 times 0 is obviously equivalent to 1. Oh, so sorry, everybody. And then we have 2 times 1, and then we have, of course, the equation. So as you can see, it's pretty basic when just learning the first part of integers. We are just, each integer, we are counting. As example 6, when we count to 6, we have 1, 2, 3, 4, 5. But to find this factorial, we are going to be multiplying each number that you count up to find the factorial. Now let's find the factorial of 6. So I'll just go back and show you guys. We have the layout for 6 at the bottom of this chart. So we're just going to be counting up to 6, and we're going to be multiplying it. So by multiplying each number, we will be able to find that the factorial of 6 is equal to 720. So we multiply 1, 2, 3, 4, 5, 6, and that will equal to 720. After learning how to solve a factorial individually, let's try when we have 2 integers. I have the example down below. We have 2 integers on top of each other, like a fraction, factorial fraction. And we're going to put them on top of each other. Most that I've seen, I'm not sure, but it's more common to put the largest number on the top compared to the bottom number, integer. So we'll be solving these 2 integers, 7 over 5, and of course, like I had previously stated, we are going to be counting up to the number of 7, just like when we're finding an individual factorial. So we're counting up 1, 2, 3, 4, 5, 6, 7, and we're multiplying them. And then obviously On the bottom, we have the fifth factorial where we are counting to 1, 2, 3, 4, 5. And so when we're finding the factorial for these two integers, we are actually going to be canceling out all the common numbers that they both share. So 1, 2, 3, 4, 5 will be canceled out till we are left with the numbers, like, of course, that 5 does not have, and we will be multiplying those to find the factorial. So after canceling out the numerator and the denominator, we are left with 7 times 6, and if we multiply that, we will find 42 is the answer to this equation. Factorials, so, of course, it tends to grow. It just shows, factorials are so, like, fast paced, and they just are growing numbers because you are multiplying multiple numbers by each other. So let's say, of course, we can go back to these slides. If we were to find, of course, the difference between finding the factorial of 5 is actually almost a 600 point difference. So when we are finding the factorial of 5, that would actually be 120. And so you can just see how fast it grows just by, that one number above by 600. And also, if we were to, of course, let's say we're finding the factorial of number 7 individually, like when I pull up this integer, how it's laid out, that actually jumps up to, let me recall, 5,040. So that can just illustrate how fast, these can grow. And this is a very great way of, finding the probability. And factorials grow exponentially. It is said in some cases the growth of factorials is faster than that of exponentials. So yeah, it's absolutely, it's a great thing to be learning about for sure. Now I am done with my slideshow, but I would be very interested in discussing more about, integers and factorials. So just like what the website I can recall, Britannica, factorial mathematics, the product of all positive integers less than or equal to a given positive integer and denoted by that integer an exclamation point. Thus, factorial 7 is written 7 exclamation point, like we went over. And that means, just like I said, we're going to be writing it out like that, and that's how we will be moving forward. It is not, of course, me explaining the, beginning part of factorials. It is not too hard to grasp in some cases, I would say personally, but it's a very fun way to learn something new, and I thought maybe making this PowerPoint and the flashcards could, of course, help in learning more about factorials. I know I learned more about factorials, of course, on top of this, and I was honestly shocked about, how fast that they grow. It's been a really long time since I've actually dove back into factorial, so I was actually really happy that we got assigned this project, so I can refer back to them, and this is a very interesting learning experience because I feel like I'm never going to forget it now that I just did a video presentation over it. But Thank you so much for watching and have a good one.